Hey guys, so this lesson's all about practice. Nothing new, except that you're going to see some of these solutions work out in some unique ways. So what I'm going to do is just go through the day 3 practice with you. These are the practice problems we've done in the last 2 lessons. So I'm just going to flip over to the back and we can do the day 3 problems. Okay, so these are the problems just at the top here, just a continuation of the last page. No notes that we're going to complete here. Again, you're just going to see that these solutions are kind of unique, and then I've got a bunch of practice problems for you to work on when you're done watching this. So we'll go ahead and solve this first one here. The inequality on the left works out to be x is less than 4, and this says or. This inequality here, once I multiply both sides by 3, is going to say x is greater than or equal to 3. All right, so this is an or statement. So I'm going to go ahead and draw my number line here, and I've got my 3 and my 4 on the number line. At my 4, I'm going to have it open, and at my 3, I'm going to fill it in. Here's where it gets to be a little different from the previous ones, because we've seen disjunctions in the past that end up doing this on both sides, and that's not how this one's going to work out. As you can see, because of the language here, it says x has to be less than 4, so that's all this stuff. Now remember, all of these numbers are less than 4. So 5 is not, if we go that direction, but if we go to 3, that's less than 4. If we go to 2, that's less than 4. Negative 80 is less than 4. So I want my arrow going that way. And then meanwhile for the 3, that says x is greater than or equal to 3. So here I want that arrow going this way. And the reason I'm not stopping at the 4 is this doesn't say and, it says or. So if we think about numbers that satisfy this inequality, and I pick the number 5, for example, well, 5 is not less than 4, but it is greater than or equal to 3, so I can use 5 as a value in my solution here because of the word or. Same with a number like 0. 0 is not greater than or equal to 3, but it is less than 4, so I would be able to use 0. And what you notice here is that every number from negative infinity all the way to infinity is covered under this statement. So my solution set is actually every real number. And this is another way that we could write negative infinity to infinity. So sort of a unique situation there. If we get a disjunction where the arrows overlap, then our solution is going to be all real numbers. All right, over here for the second one, I'm going to split these up into the 2 conjunction cases like I've done in the past. All right, now I'm going to go ahead and solve these individually. So I'm going to have 2x is greater than 4, and that means that x is greater than 2. And simultaneously, x has to be greater than 9. Okay, so if we put this on a number line, I've got a 2, and I've got a 9, and I've got 2 open circles. So x has to be greater than 2, and x has to be greater than 9. So here you're seeing both arrows go in the same direction. If I wanted to pick out all of the numbers that satisfy this as well as this, it's really just going to be these numbers, right? Because I can't pick numbers out here. Those only satisfy x is greater than 2. So ultimately, the solution to this conjunction is just x is greater than 9. And that x is greater than 2 really doesn't have any bearing on our solution because all the numbers greater than 9 are where you find the values that are greater than 9 and also greater than 2. Another way that I could write this would be to say all the values from 9 to infinity, if I wanted to use interval notation here. Number 3. First inequality. Now I'm dividing by -2 here, so I'm going to want to flip the inequality. And now in this situation, I'm not dividing. Don't divide by x here. Sometimes people are tricked into thinking that might be a good idea. I'm going to just subtract x from both sides and end up with x is greater than 0. So I have these two statements. I'm going to go ahead and put those on a number line. -4 and 0. All right, they're both open. So x has to be less than -4, and simultaneously, x has to be greater than 0. Where are the places that you'll find numbers that are less than -4 and also greater than 0? There are none. So we have no solution here. So when we have a conjunction and there's no overlap, there's no solution because there are no values here that are both greater than 0 and also less than -4. All right, now for the fourth one, we're asked to write a compound inequality that describes the given graph. And I'm just going to go ahead and draw the graph that I want you to try to write an inequality for. All right, so I decided to draw two here for you. And I'd like you to go ahead and write what that says as an inequality, and then write it in set notation as well for each one. And now I'll go ahead and write my solutions out for these. So for the first one, we've got x must be greater than or equal to 3 while also being less than 5. So this is a conjunction or an and statement. Another way that I could write this is in set notation. I could say from -3 to 5. Either one of those, both the same thing. And for number 2, I would say x has to be less than 2 or x has to be greater than 11. And another way to write that in interval notation would be from -infinity to 2 or from 11 to infinity. All right, so I've got a set of practice problems for you guys to work on, a whole sheet of inequalities for you to solve, and then a homework problem or a homework set tonight as well.